Good evening, one and all present here. I welcome you all for this day four session. Day four session on behalf of R.M.D. I welcome you all for this session here. So today we have two sessions. Uh, the session one will be given by Mr. Kumar of CoreEL Technologies. I welcome you, sir.
Thank you, ma'am.
Now I invite Ms. Srinidhi to introduce the guest. Over to Srinidhi.
Good evening, everyone. It's my pleasure to introduce Mr. Kumar, who is currently working as application engineering at CoreEL Technologies. He brings over 4 years of industrial experience in field of VLSI design and verification. Mr. Kumar has been with CoreEL Technologies for past 2 years, where he works extensively on FPGA designs using AMD, Vivado, and Vistas. He is skilled in stimulation, synthesis, and place and route, and hands-on experience with MOC, SOC, Vertex, Kintex boards. He also conducts training sessions for customers on FPGA workflows and Simon EEDA solutions, reflecting a strong technical expertise and excellent communication skill. Before joining CoreEL, he worked as a design verification engineering at Wipro Technologies, where he was a part of VLSI verification team, ensuring the functionalities and performance of UFS controllers using system Verilog and advanced SOC verification techniques. Mr. Kumar holds a bachelor degree in electronics and telecommunication engineering from Kalinga Institute of Industrial Technologies, Bhubaneswar. He has also earned certificates from AMD in designing with Verilog and design with ultrascale and ultrascale plus architectures. With a strong foundation in FPGA designs, RTL development, and verification, Mr. Kumar continues to contribute to advancement of cutting-edge semiconductors and technologies. I warmly welcome you, sir. We are truly honored to have you with us today, this evening. Welcome you, sir.
Thank you, Srinidhi.
Over to you, sir.
Thank you. I hope my screen is visible to all of you.
Yes, sir.
Okay. Good evening, everyone. So, on this warm evening, we will get to know regarding the demonstration of a few ML-driven VLSI design tools. Maybe I am not going to cover the entire aspect of it. Maybe a demonstration portion of the ML machine learning application with one smart camera application. So that I'm going to show you. So that is what regarding today's agenda. Moving further, discussing about what are the things we are going to come across. Firstly, we will see what are the artificial intelligence point of view, and then machine learning and deep learning. So, as part of a machine learning, what is machine learning and how we can go ahead in understanding the application level implementations that we'll see, and then we'll move on to the deep learning module where we concentrate on neural networks, and then what are the frameworks are available for the deep learning tools, and then what are the network models available for the general cases, and then I'll be walked through with the AMD's smart vision applications that is using one of the hardware which provided by an AMD. So this is what the agenda of today's discussion. So to get started with an initial understanding, so in today's world, day-to-day life, we see maybe in terms of an automations or home automations, or in terms of advancement in cloud technologies, or in the AIML applications, whatever we see today now. So maybe it in the ADAS, or in the cloud computing, or even the data centers. So we'll find out all these phenomenon with these three technical terms, One is an artificial intelligence, and then machine learning, and then deep learning neural networks. So this is what the correlation is. So what is mean by an artificial intelligence? So it is a thinking ability similar to a human being. Okay, as being a human, we should think differently, right? So same way we need to model maybe a robot, and then designing a robot, and then making it has to be thinking in a way of intelligence. It has to decide. So example, maybe an object detections, object identifications. So that is one of the intelligence that we require. So how do we treat this as a one entity? So when we take an intelligence as a one entity, then we need to incorporate, there should be some sort of learning, right? So for the intelligence to give example, I just wanted to understand the uh, manufacturing industry where the chips will be manufactured. So I need to understand what is the size of a chip, right? So I need to like classify the chips, maybe this in terms of width and height of the chip, or the breadth of the chip. So how much it is. So let us say if I have x cross x as one of the chip and x cross y as another chip, then how do I differentiate this, right? So there will be some machine learning. Machine has to be learned using certain algorithms, right? So for this we require certain things called as a data sets. So that is where we train the intelligence. We require our data sets to be given, and that requires lot of learning. So that learning can be done, we call it as a machine learning. Then we'll move on to an internal entity of a machine learning, which is basically your networks. So what type of networks you are going to adopt, whether it is a any network which is available in the today's world. So we generally call them as digital neural networks, or DNNs, or deep learning neural networks, where we are going to have the prediction of any machine learning algorithms. So using among these DNNs, we are going to choose maybe a CNN, MNN, or an RNNs, any of the algorithms, so that you can use it for the machine learning, where it will leads to the intelligence. So we basically want an AI to behave like a human itself, and then what are the those behaviors can be predicted in terms of an algorithm, and we need to train them with a lot of data sets. So basically, we know as much of data sets we load, the accuracy value and then prediction value will be giving you a faster results. So that is what it's a, I can say it's an umbrella where we require a deep learning neural networks, and leading into a machine learning, and then artificial intelligence. It's like we are under the roof of a tree. Okay, so it's starting with the roots, and then go to the stems, and then leaves, and then other things, right? Other branches, I can say. So that is where it will leads to an intelligent machine. So getting into more detailed about what is machine learning. Okay, so there are many classifications in the machine learning. We call it as supervised learning, and secondary we call it as an unsupervised learning and reinforced learning. So what is supervised learning? The learning is based on the lot of informations which is already available in terms of a large volumes. So that is supervised learning. So that we need to give the guidelines for a machine to understand. So example, to be a supervised learning, maybe a pedestrian movement. The pedestrians has to walk on the footpaths, right? Vehicles has to be traveled on the roads. This proper guidelines has to be given. That is one of the example of a supervised learning. What is the unsupervised learning? The algorithm which is we going to categorize it based on that. Say pedestrian means only these things. Sometimes they can come onto the road, but what is there on the zebra crossing, only they need to cross the road, right? So like that. So we have to have certain algorithms to be developed. Okay, with the algorithm we run, then it is an unsupervised learning. So with the already existing data sets, maybe loading a lot of images where the people are crossing on a zebra crossing, all the set of data sets we need to give. That is your supervised learning. And then coming to a reinforced learning, we have something called as a trial and error. Okay, so it is like we force some data, what will be the expected results? That is what we are going to expect, right? So that is how the reinforced learning will be happen in machine learning. So as part of this, we have a deep learning neural network. Okay, how exactly it will start? So we feed an input layer. Okay, so it is like we are mimicking the entire thing, correlating to your human brain. Okay, so your human brain is controlling your all the parts of the body, right? Similar to that. So then the brain is connected with the, so through the brain, so we are going to connect it to a spinal cord, and then it will be spread across the various parts of the body. Similar to that, we have a lot of layers within.
Kumar, I think you're muted.
Sir Kumar, sir, kindly unmute, sir. Thank you, sir.
So I was talking about there are multiple stages in the machine learning, which is supervised learning, unsupervised learning, and then reinforced learning. So within that, how we can build a deep learning model. So deep learning model taking an input layer and predicting its response at the output layer. So in between this, we have a lot of layers. So it can be maximum extent of 8 layers also we can have based on the algorithm what we develop. So maybe it is a RNN or MNN or CNN, say any of the things. So that we can incorporate. So these individual layers will contribute having a multiple nodes. So each and every nodes, it is like a checkpoints. So what is the prediction value from these many models? So what is the first prediction? What is the second prediction? Third prediction? Like that, we'll have a lot of predictions in individual layers. It is like example, unofficial expression. So I wanted to know the movement of eyes, the iris eyeball movement. That is one of the layer I can say. And then maybe on the cheek, the movement of the cheek. That is how. So we are going to have classification each and every organ of our face. Let us say. So we are going to have a different layers to predict the behavior of it. Finally, we will make it as a ROI, okay, for individual layers, and then we'll comprise it to as a face. So for the face detection algorithms. So like that, lot of computations we required, and we need to predict uh, individual nodes. What are the? It is like a checkpoints. We are going to predict the value of the checkpoint in terms of an algorithms. So coming to the history, so it started in 1940s with analog computers with neural. It's modeled with the neurons, and then later in 1958 we have based on perceptrons. So and then we in 1990s it's an AlexNet where it is having an 8-layered algorithm. Now I think I can see the lot of algorithms are improved, and then a lot of computations are increased nowadays. Maybe the advancement in GPUs and all. So we lot of computations in a fraction of seconds. Even you can see in nowadays with AMD's few GPUs also it will be supported for this. So that is how the evolution has happened in the machine learning. And what are the applications that we are focused with rapidly evolving technologies? So as we see in the chip industry, so we are going to find out the lot of changes in the technologies, right? So we have seen that starting with a MOSFET technology, and then moving on to FinFET technology, and then moving on to GAFET, and then now I think CFET is in the industry now. We're dealing with an 1 nanometer. Uh, 1 nanometer transistors on a chip. Okay, that is a lot of changes that we are finding out, and then a lot of acceleration in terms of cloud computing and edge applications. So AMD is always one step ahead in ML based applications and cloud computations are in data centers. So what are the market trends, that what are the market we are in? So we are into autonomous vehicles, maybe advanced driverless systems. We have autopilot drones. We are, and then we are in personal robotics, and then even we'll have in the data center where high performance computing, and then we are in the security in lot of the hardwares, and then whatever. The machine learning algorithms are required as security. We are having a lot of security features. So that is one. And then financial services, we're in manufacturing and engineering, and we are in medicine. So maybe in medical domain, we see a lot of growth where we require an ML application. So we can see that the machines, so the whatever the scanning machines or MRI machines, all those things in a medical industries are based on this AI era. So where it requires a lot of machine learning. And then we are in energy as well. So maybe in sustainable energies, solar, wind, or any other thing. And then we have a personal assistants also. Now we can see on your fingertips using your smartphone. So you are having an access to Siri in iPhone like that. So we have a lot of features, right? So which is based on maybe from Google Assistants. Also you have some the Android like that. We have a lot of personal assistants also where the machine learning AI is booming. And then even the marketing strategies also where we have access to Amazon Web Services also. So where we predict what are the strategies required for a marketing. All these things comes under an umbrella of a machine learning applications. So it is not only extended to only for these restricted to these applications. It can be uh, uh, like predicted for some other applications where in later onwards we will see a lot of development in machine learning. So what are the major applications we AMD concentrates on is maybe in edge ML applications where the surveillance and surveillance is one of the essential need nowadays, where the person is traveling, and then whether maybe just to take an example of maybe the monitoring of traffic. So where we wanted to understand the behavior of the person, so whether he is properly crossing the roads on the zebra crossing, or he's moving in the pedestrians, or the safety of the uh, uh, in each and every individual in the society is proper or not. So that can be predicted. So socializing everything. So we have a surveillance maybe in the public transportation as well, maybe in metros or public transports. So everywhere we see these surveillances, and then even the ADAS. So in automotive industry also a lot of growth has happened with the machine learning. This one, and maybe you can see in your vehicles also, automotive vehicles. So you find out the parking. Also, it used to be helpful nowadays with respect to the cameras in sessions, or are predicting the lanes, for the parking, all these things, like which has evolved like anything. And then even the robotics also. So maybe in robotics we have a lot of robotic arms. So maybe in the medical, agricultural, or any other applications. So all those things comes under an HML applications, where which is an essential need for our day-to-day life. Apart from this, these all applications require a lot of storages, right? So where it will comes. So once again, we need to have a data centers. So let us say with one video, we are going to have a 500 MB of memory. I need to store it, right? So we require a certain space, right? Maybe in the Google Cloud, you can put it, maybe a 1 TB of space will be provided for you. But whereas in the cloud, if you put it in the data centers and all, lakhs and crores or trillions of data can be stored in the data center. So that is also one a challenging part. So that is also been predicted using a machine learning algorithms also. So the memory allocations is also dynamically given. So that is where these applications will lead into a lot of computations. Moving further, what AMD gives you. So maybe to give you an overview. So we have a lot of deep learning applications with us. So for both edge applications, and then maybe we have data centers also, which is maybe with the AWS or Alibaba or Tencent or Nimbix or and so on. So we have certain graphic controllers as well as accelerators also to supporting it. So one of the edge applications where we take up the stream of data, maybe in terms of the cameras. Okay, then we will have a computations can be done using our hardwares, FPGAs. So basically, we have the Zinc Ultrascale plus MPsoft devices, and then Kriya modules, and taking further to an accelerator with respect to an Alveo card, and then we have also have the Vertex Ultrascale devices where we concentrate on the cloud. Okay, where the data centers where we need to manage the data centers, so that directly the computations can be handled using our FPGAs. So that is where a lot of computations we offer from AMD point of view, as being a part of a CoreEL. So we cater all the requirements to educational institutes. So coming back to this machine learning algorithms, we develop with deep learning models. We have a specific processor called as a Mali, which is going to take care of this, and then we'll also have a video codec unit also for the live stream of our videos. So all these things comes under the machine learning applications. So as I mentioned earlier, so coming to a deep neural network, it requires a lot of computational layers, and these are all connected to each other. So the reason of connecting each other is that prediction of one behavior with another, and so that the functionality or the essential point should not be missed. So that is where we place each and every computations adjacent to each layers, and then we predict the nodes behavior, and then based on those we retrain them. And each nodes, no, whenever we predict, so a lot of computational power is required for that. So we essentially required any hardware which is taking care of these computations should be efficient and then deterministic. So when we say to taking any of the today's world applications we see in the real time, so a lot of translation models are required. Maybe we'll take an example of a Google Translate model. It will require around 2000 GPUs to predict the output layer. So just like just imagine 2000 GPUs are required to predict one functionality, how hard it is, right? So the computation of GPUs also are essential nowadays. So that also we have to concentrate on. So coming to the use case, and then what are the uh, what are the points that we key points that we need to concentrate on is, So one is on power. Definitely, that is essentially is required. So let us say you have the uh, device with you, and then if it is consuming a lot of power, it is draining out like anything, then it is of no use, right? So you require a lot of power, computation power, and then you need to save the energy as well. So that is one point. Then huge set of training data that we require secondary. So if you don't load the data properly, then probably it might result in improper predictions at the end. And coming to it, lastly, the error rate. So the model which you chosen, whether it is going to give you the error rate, okay, how much error rates, how much error detections, and how much corrections it is incorporated in the neural network. That is essential for designing any of the machine learning. So we required any DNN will be backward compatible. So when we like compress certain informations and pass it over certain places and then retrieving it back while decrypting or while decrypting, we must have to express the same data will be received, right? So we should have both the ways, like forward propagation and backward propagation, we call in terms of DNN. Okay, so we when we send certain data with the trained models, okay, we need to label so each node. So whenever we say the multiple layers, let us say object identification itself, and a human or a animal or a pets, so I need to identify, right? So for that, a lot of training data sets I need to load as an input initially. So individual test cases I need to take and then predict it. So similarly for any factories, okay, any objects in the factories, maybe water bottle manufacturing, or maybe the household applications wherever we manufacture. So the objects, different objects and different test cases, different training models, we need to give it to a machine learning. So once this machine learning will take and pass it on to a deep learning model, this deep learning model takes each and every data sets, and then it is going to compare each data sets to another data set, and then results in one type of classification. So we'll do the certain classification with the layers. Okay, so these classification that we will discuss later. So for each classifications we have to label. Okay, maybe a human detection, so we need to name him as a man or a woman, like that, right? Sub classification also should be incorporated in the design. Moving further, the training model, how it will start. So it will lead into inputting a data. We need to decide upon the machine learning algorithm, what type of algorithm, and the input data. You see that the lot of training data are required. Where machine learning algorithm you use, taking an input data, okay, it's just an input now, and a machine learning algorithm takes the training data and puts the computation and then try to match it with an input data. So let us say whenever I'm going to send some information from one place to another place, I need to send the data in terms of a packets, right? There also it's the same prediction, right? How many bits you are sent, how many uh, how much is the odd number, like how many number of ones, how many number of zeros in terms of a digital, right? So that also I should be calculative, and to find out that the parity check, right? So similar to that, so we are going to have a machine learning algorithm where we have a training data. So we are going to compare this training data, already available models, with an input data. Based on that, we'll predict. Okay. So something, let us say like when we are capturing a human, the face has to be detected. So we'll match the face only, right? So the models will take, the training models, training data will take, so which is matching with the face. So then that prediction will be given as an evaluation. Okay, so all these things, no, we'll have to have a lot of training data. Sometimes what will happen, no, we might not have a training data, so we need to take the real time data and then we need to train that, right? That is little tedious task, but it is essential. Then with that predictions we need to label, and then we are going to have model which is using already existing training data and to give you results. So that is your output or the prediction of an outcome. Okay, so that is comes where and you are going to evaluate the entire machine learning process. Next is the training, and training is one part of it. The another part is inferencing. So there is a lot of difference here. So where AMD uses both the main methods, training and inferencing. Maybe like example, already a model is tested. I wanted to retrain it. I need to give you a more accuracy on it. So that is where inferencing will come into picture. Okay, so in the training model we have a lot of frameworks, lot of data sets. Okay, a lot of neural network models available. Then with that we will identify, compare the input data, and then with the data sets, and then we'll come to the prediction. When the prediction is comes, the accuracy we need to find, right? So for that we what we do is we are going to optimize the data. So that is where the performance we are going to predict it. So that is where the inferencing will plays a vital role. So we need to do this an iterative method. Okay, so where the correctness of the algorithm can be maintained. Okay, so we have a lot of GPUs, strong GPUs for the training. So a lot of capabilities are there with respect to GPUs to handle AWS and other things. Okay, so this is regarding the comparison from a training to inference. So moving on to what are the trainings, how exactly the training will happen. So you see here, there are a lot of test cases I can say. We have NIST and then Cassia and then Google Street View, and then we have ImageNet, CIFAR, and all these things. No, so these are all certain case studies, or I can say it's a training. So character. So when we take NIST, then we have handwritten digits. We have around 60,000 samples. For the Google Street View, we have around 6 lakh samples like that. So we have millions and trillions of model for individual test cases and prediction. So what are the stages? As I mentioned, in the DNN, as part of the DNN, we'll have a lot of other prediction algorithms. Okay, so all these things follows three things. One is classification of network, secondary is on detection of network, and then thirdly on segmentation. Okay, so what first initially classification does is we'll identify an object, right? Once we object identified, okay, say let us take one image we captured. Okay, so we say that whether it is a, just to take an example of this only, we have a dog or a cat production, right? So cat, we are going to take that, we classify them as a cat, right? Next, if is there any other things are there, okay, detects other objects within the image. So not only cat is there, we'll have a dog and then we have a duck also, right? That is where we have a detection network. So we have provide the classes, locations, what are their probabilities, whether the dog is having a probability or an accuracy of 100%. Okay, that is your probability is maximally 1, we'll take in terms of percentage and 100%, like that the accuracy value we are going to predict with the detection network. Then we'll do the segmentation, so we'll do some labeling. Okay, each classes, let us take here in the last image segmentation, we'll see bottle, cube, cup, and a cube. The shape they have augmented, right? So there are certain examples which AMD provides, that is given here. So I think I have added this to give you overview, training and inferencing. Okay. So usually whenever we do inferencing, it should be a trained model. So maybe what are the model sets that I'll discuss later? What are the models that are supported by AMD? So these are the frameworks. The maybe you can consider it to be models. Okay. So when we do inferencing, a lot of libraries and tools are required. So for building a machine learning models, then we'll move on to the available tools, so open source tools, and already available built-in algorithms, and we using those algorithms we develop our own algorithms. Like that the framework can be assigned. So we'll have mxnet and then darknet, keras and tensorflow. So these are some of the frameworks that is supporting to dnn. And you can see here the lot of once again the predictions I can see. It is one of the like prediction of motor or a scooter, so like that. So sub classifications. So whenever we take in any object, so we need to classify, right? So taking an image recognition, so entirely on a stream of data itself. So with that we need to predict, right? So everything we need to classify as a different classes and subclasses we should require, and lot of images, multiple images we need to store in order to augment the reality, right? So for that we use lot of frameworks. So moving further, the frameworks which is already available, which is PyTorch and TensorFlow, which is most commonly used in most of our designs. Then we have a lot of network models, maybe AlexNet, VGG, or GoogleNet, or ResNet, or SqueezeNet. All these things are network models are available. And then training data sets, we have a lot of training data sets. Maybe we'll not restrict only for a Google Street or ImageNet or any other thing. Okay, so there are other efficient models also we need to incorporate. So individual network models will specified for one set of applications. Example for like ResNet model, which is used only for tensor flow model for image classifications. Like that, there are other uh, network models which provided by a vendor that we need to understand and then make use of those models. So as AMD point of view in ML task and network models, we segment machine learning tasks into three things. One is classification, detection, and segmentation. So we have a lot of applications for that. For classification, we have BN Inception, ResNet, SqueezeNet, MobileNet. Okay, and for detections, we have SST, ULO, and DenseBox. And then for segmentation, we have FPN, and that is entirely a deconvoluted version. So basically, we do a lot of convolution. So when we talk about a CNN, lot of convolutions we need to do, and then we need to predict the behavior of that model. So this is how one of the examples showing detection of a single object or a multiple objects. So you can see on the top images: face detection, pose estimation, video analytics, lane detection, object detection, and segmentation. How it will be done? That based on the labeling, based on the color coding, also we can use it, right? So you can see here in the bottom part we have classification and classification plus localization. So localization is similar to your ROI, region of interest. Okay, and then see, for cat it is red, and for dog it is blue, and duck it is green. Like that we can take, and then the placement, how much, where it is placed, and what locations, what segments that is utilized, that you can see in the instance segmentation. So now coming to AMD's vision-based applications, what are the tools that AMD uses? So we have maybe I have generalized it for one of our board, which is KV260. Okay, but it is holds good for any of our devices. maybe you can take zinc ultrascale MPSOC device. These are the mandatory platforms we are supposed to use it. So we have AMD YTs, which is for an embedded application development. And then we have on the embedded applications, we'll have acceleration overlays. Maybe this will be supported using your Python. Okay. So, and then even any of the framework or models, which is your AI model or machine learning models built using TensorFlow or a PyTorch. So for this, we have one specialized tool called as YT's AI, okay, where it will have around 200 plus AI models. We call it as a model zoo in AMD. So we have a lot of models already available. Maybe whatever we listed, ResNet or ImageNet or other thing, all those models are already available. The only thing is you need to pre-train these models. So we'll follow certain steps, something called as we have quantization, compilation, okay, and re-identification of the objects. All these things can be done using YTZ. Okay, so for all these things, basic base model will start with the accessing a peripherals within a hardware. We require a Vivado design suite. Okay, we require Vivado, YT's, acceleration overlay, and YT's AI, where we are going to customize it. Where Vivado design suite, how it will help us in accessing the maybe let us say I am going to access an HDMI input stream of data, then I must have to make use of an HDMI live stream data. That is one thing. Secondary, I must have to use sensors, camera sensors, use of cameras. All these things I need to incorporate, right? So that is where we required the Vivado design suite, where we configure all the peripherals on the hardware of AMD. So we have the Kriya module, which caters on a lot of AI, vision AI based applications, which is focused on machine learning. So we can use those modules for security cameras, city cameras, traffic cameras, retail analytics, machine vision, and mission guided robotics. So you can see this is one of the booming region where vision guided robotics is nowadays is playing a vital role. You can see that in certain drones are delivering the parcels from one place to the another places, right? In few of the countries. So that you have seen, right? So that is how the lot of scope for the hardware accelerations. Okay, so where these hardwares are essential in order to control and then do the computations. So instead of a GPUs only, we can able to handle with this accelerated devices. So as you can see, what are the platforms we require. So as soon as we concentrate on these machine learning algorithms and all and algorithm development and all, so we required the support, right? Support is from the platform, maybe the OS support. So all these developments what we seen in the today's world, it is based on the Ubuntu. So that is one thing. Secondary, we have what is AI model, where you have all the deep learning frameworks are incorporated. Basically, we use TensorFlow and PyTorch, and then we have any OpenCL based framework you wanted. Then we can go ahead with an embedded application development using AMD YTs. These are the three platforms which is being provided by AMD for the AMD hardwares. So coming to the Kriya KB260, this is the board that we are using. Okay, so for the demonstration purpose for machine learning algorithms. So we have the two devices on this model. One is a carrier card, another one is a SOM. So SOM is basically a hardware device. interacting with the peripherals provided in the secondary devices, where secondary devices will be provided with a boot image. Okay, the boot image will be loaded with applications, which is smart camera in this application. Through that, we are going to load the QSPI memory. So we'll have two partitions on the hardware. One is primary and another one is a secondary. So primary is your firmware and secondary is your carrier card supporting with an SD card image. So SD card image is basically accessing the peripherals on the hardware, where firmware is locating into the device. So both isolations are meant on the device and they will be configured together. So without a firmware, if you load an image, it is of no use. So it is like a combination of both primary and secondary device. So the lot of resources, right, as mentioned in the previous slide, where we required the firmware, which is boot.bin, okay, which is a primary device. That firmware is loaded, as we call it, as the four different classes we have. One is first stage bootloader, FSBL, and we'll have a platform management unit, and then we have on trusted platform, okay, which is basically a processor, right? So we have executive linker files loaded for that, and then we have U-boot. Let us say uh, in the like primary device, we will make two partitions. Usually, we'll have two partitions in this primary device. Whenever the primary device, one partition, if it is not working, then we have to move on to the other partition, right? So that's why the image A and B is provided. So if in case of image A is um, crashed, then we can move on to the image B. So that handoff is taken care by U-boot. Okay, sorry, we call it as a universal of the image to the another part of the image. That means we can call it as a partition. So without a U-boot, if you try to load, then it will not be able to perform. So all these things as part of a primary device. Then what we do is we'll take a handoff to like link the image file in the secondary device to a firmware, and then we'll access the root systems. Then we'll move on to the actual implementations. So what AMD Kriya uses is one of the specialized platform management. We call them it as an XM util. Okay, it's an utility supporting to the applications of an object identification, like natural language processing, defect detections, and smart camera applications. These are the applications that the AMD Kriya will be supported for as part of the machine learning algorithms. So, and even we have AI box where re-identifications of an object also can be done. Okay, so what is the idea behind this is we use video analytics technology for this. So we analyze the video content and extract the meaningful information from video, and then we will going to decode it, and then once it is decoded, then we'll pre-process it, and then we'll perform a machine learning, and then we will perform encoder and we'll stream it. So basically a movement of like streaming of a real-time information or a monitoring, and then to detect a particular object or the movement or the pattern or the behavior of the things. So we have something called as a VVAS. So we have VIDIS, video analytics systems, which is going to take care of this. Okay, so at the end, streaming out through maybe a monitor or a display or through certain gadgets that can be done. So all these things are based on one of the framework which AMD provided, not AMD provided, it's an open source. So you can make use of the framework, which is basically a GStreamer. Okay, so GStreamer is an open source that you can develop any process which is written in C language. Okay, and basically this is supporting to a Linux platform, and these GStreamers will operate dynamically at runtime. So, and it also requires a plugin. Okay, it is like plug into an application development. So in the multimedia block, we have a capture to display in between where the compression and decompression or scaling can be done in the multimedia blocks. So that is where GStreamer framework is meant for the processing application. So as I mentioned, Viva's platform applications. So our Zinc UltraScale plus MPSoC based embedded platform and virtual device based platforms we have. So that uses a smart camera for face detection, display functionalities, and AI box with re-identification, demonstrate multi-stream tracking and re-identification, detects defects in products, and then natural language processing using audio, maybe a mic you can use it, maybe the movement of like unified the robot, right, left, right, straight, backward, right, the movement you want to control, right, using a natural language processing, that is also being possible using our Kriya modules. So that is where the platform Vivas will supports for that. So what this Vivas does basically, it is going to take an input data, maybe the camera interfaces, maybe USB based camera or MIPI CSI, or video file from any like basically the image what we load, no, it's not of MP4 but .HT264 type of videos we are supposed to store, and then streaming over RTSP, that is also can be done. And then next we'll move on to taking this input data, we'll decode using video codec unit, pre-process the data, then we'll move on to what is AI environment, where we'll gather information pixel by pixel, and we classify them, and then we retrain them, then we final to the AI inferencing as an output. So these are the things. The solutions will be in traffic or pedestrian movements in smart cities, monitoring health and safety in hospitals, and providing self checkouts and analytics in retail malls, or maybe in the outlets, retail outlets, and then even detecting a component defects in the manufacturing facilities. Maybe when we take in fruit market industry, right, food industry especially, maybe identification of a rotten apple or any of the fruits, right, like that also you can detect, so using video analytics solution. So that is where it's playing a vital role in our day-to-day life. So the accelerated applications is one of the applications that we focused on. The today's session is on smart camera. So we have built-in cameras, or you can have multiple cameras interfaces to Kriya KV260 board. Then we develop a machine learning algorithms, maybe for this is only for a face detections, so like that counting a people, maybe some other features also you can incorporate apart from these things. And we use DPU for this. So how the process will take, we'll have sensor interface, okay, maybe audio camera or something, then we'll move on to neural network, where we'll do pre-processing using DPU, and then we'll do streaming out using an RTSP or through HDMI out, okay, or display port. So finally, this we can interpret using a Linux platform, where we have two segregation in an FPGAs, which is PS and PL. So processing system as well as programmable logics, both the things are being used in the applications. Then we'll stream out that using an HDMI or a DP port. So we will move on to the one of the demo. So the requirement for the demo is we require a Ubuntu machine, and so as of now we are not using Vivado or Vitis or Petal Next tools. These are the tools are required for training a model and everything, development of an image file, everything we required with these three tools. And hardware, what we required as a Kriya, and then we required a micro SD card supporting to this, and then power supply. So and then camera module or USB webcam as also you can use, and 4K monitor, and USB microphone, and if it is in case of an NLP, then microphone you can use it. You required an Ethernet, micro USB, and HDMI port. So let us move on to some demonstration now. Okay, just this. So I'll just turn the camera on, and I'll show you. Maybe the camera I need to change. Maybe I have to rejoin for this. Maybe I'll not sure. Check the settings. It's okay. So let me show you this one as of now, the applications. And then we move on to the entire thing. So I'm using one board right now. So I think you can see the boot up image console, right? So you can see here I have Zinc MPSoft device, which is Kriya. I'm starting it. So I can show you the board hardware here. So that is booted up now. So I have to log in. I logged in now. So we have to have certain commands to be given for this. Just a minute. I hope my screen is visible, right?
Yes, sir.
Thank you. So what are the applications are available with this board that we are going to find out now? You can see here I have installed one of the application which is accelerated application, which is SmartCam application, which is supporting to Kriya KV260. So the next is what we are supposed to do. I'll just show you one more thing. So I have connected one of the display here. So as part of this demo, I have connected uh, the monitor. You can see here. So there is a monitor placed. So which is an Ubuntu machine. Okay. So that means we are having an ability can convert an hardware into a Ubuntu machine. So that is the capability of an hardware. So first thing we need to see here, whenever we have an acceleration, the active slots are there. You see here -1 and 0 will be given, right? So this is an indication that which other the application is loaded or not. Okay. So what we do is, for the better case, we unload the app. So I told XMUtil is a platform which the AMD is provided for the application development. So I'll unload the app. You can see remove from slot 0, return to 0. Okay. So now what I'll do, I'll list. Okay. List apps. Now you can see here both the active slots are -1. Earlier it was -1 and 0. So that means this 0 starter kit is loaded for the application. So next what I'll do sudo xmutil load app kv260 smart cam. I'll give application will be loaded. You can see here kv smart camera is active slot is 0. That means my kv260 smart camera is loaded as an active. So now what I'll do, since I use my monitor as a Ubuntu machine, I need to disable that. Either I can use a GUI based here with the terminal, or I can use a Ubuntu machine. So I'll disable the Ubuntu machine. So I'll use sudo xmutil desktop disable. Okay. So once it is done, the AMD uses specialized a platform called as a Docker. Okay, that platform, so we need to take. There are certain commands which will be provided for the Docker. It's universalized, centralized for Ubuntu machines, so that we need to run. Once I run the Docker, okay. So before that, before I'll run the Docker, so I'll just want to just hang up. So so just before that, I'll just find out what are the folders are available. We have a support directory, and just for that what I'll do is I need to copy for certain things. So I'll just go to support. I'll list here. This we have three classification. A box we have defect detection. We have a smart camera, but we required only a smart camera, right? So what I'll do is I'll copy a smart cam, all the files. So what is there in the smart cam? Just I'll show you. So we have certain image, that means stream of videos in terms of .h264 format. So that is what we have. Okay, now what I'll copy smartcam slash all to slash 10. So this is in your Docker. Okay, you're copying the files into this one. Okay, sorry, I have given smart cam. I'm not given smart cam. That's why it is showing. Okay, now it has gone there. What I'll do is I'll copy this Docker, then I'll paste it here. So now you see board is booting up with a loaded smart camera application. So you can see Kriya Som is up now. Now what we do is, so we'll move on to the application. KV260 smart cam beam. So what is there in this? You can see a lot of things, right? So we have MIPI, DP, file to file. So file SST, DP. So in this third one, we'll run it from the file. So for that, what we'll do is 03. We will see what is there in this. You can see here, this application required a smart camera. From a file it is going to run, and then target width and height. So it is stored in a file, right? So like that it will be operated. So what I'll do is I'll just run a script smart camera from a file slash temp slash smart cam. So let me move on to this. VLL. What is there in this? This 03 is there. SmartCam file / temp / SmartCam slash is not listed. Okay. Yeah, we have temp, right? CD ls. What is there? Yeah, we have output ADAS, right? Okay, within this temp is there, not smart camera. So you can see here there is two files which is copied here. So what we do, we'll run this smart camera file output underscore face detect in file type h264 target dp. I'll specify the width as 1920 and height as 1080 and frame 30 frames per second. Use a task. Run this. Now I'll just turn my camera on to show you the image. So you can observe now, right? So there is a face detection is happening, right, on the stream of video. So this is an algorithm which is developed using machine learning in order to identify it. In a stream of video, okay, what video I have loaded, for that the smart camera is working with a face detect. So like this, we have a lot of models available for the use case. So this is about a smart camera application using an ML. So these are the tools and requirements for AMD to have. Okay, so we'll require a lot of these computations using a machine learning algorithms. So with this, I'll conclude my session. So open for questions if you have any.
Thank you so much, sir. Participants, if you have any doubt, you can unmute yourself and you can ask the doubt, or you can post it in the chat box too.
So meanwhile, I'll just share one of the file for feedback. I think kindly provide. This is required for our internal use. So please do provide your valuable feedback on the session. So if any questions, we are open for the discussion.
Participants kindly fill the feedback form that sir have shared in the chat box. Sir, I'll share this link in the WhatsApp group also, so that and I'll request the participants to fill the feedback form also. So, thank you so much, sir, for accepting our invitation, and you have shared your expertise among us. Now, I invite Ms. Sendil Priya to deliver the vote of thanks for the session. Over to Sendil Priya.
Good evening, everyone. It's my privilege to deliver the vote of thanks for the wonderful first session. So, on behalf of the R.M.D. Engineering College and Department of ECE, I extend our heartfelt gratitude to Mr. Kumar, Application Engineer at CoreEL Technology, for engaging us in insightful session and on demonstration of ML-driven VLSI design tool. Sir, your practical demonstration and detailed explanation of ML application in VLSI design have given participants a clear understanding of how modern tools are transforming semiconductor workflows. We truly appreciate your time, effort, and valuable contribution to the faculty development program, sir. So your session has been both informative and inspiring for all the participants. Thank you once again, sir, for sharing your expertise and making this session a memorable learning experience. Thank you, sir.
Thank you, ma'am.